So yeah, so it's important to be able to discover if there are any fields that depend on each other, right? And the only dependencies that we want to keep that are not problematic is those dependencies that if any fields depend on the key. Right? If they depend on the key, then there's no problem, right? But if they depend on each other, then it's a problem, right? We could introduce inconsistency, right? Because when they depend on the keys are guaranteed to be unique, right? So the values, because we can create constraints on the key, and then the combinations can be unique, then you don't have redundancy. But the other fields there are no constraints amongst each other, right? They can repeat, right? You can have all the different combinations, and there's no way for us to catch it, right? So it is important for us to identify these dependencies. Now, the way we were capturing these dependencies were by inspecting, right? We were looking at the actual data in the records, and we realized that, oh, wait a minute, why is this data repeating every time? Yes? What functional dependency tries to capture is that you need to be able to identify these dependencies without even looking at the data, right? By just looking at a sentence, right? By reading the sentence in the requirements, right? That should give you a clue about certain fields depending on each other. Okay, so it's a logical capture of these functional dependencies as opposed to an inspection on the data. Okay. Right. So we want to identify if there are dependencies amongst fields, and we only care about dependencies amongst fields that are not keys. Right. Those are the ones that are dangerous. Right. We need to remove them, and it also can give us a clue on what it might be that you don't know what the key should be at first. Right. It's not evident. It's not self-evident that certain keys might need to be. And functional dependencies might give us a clue which fields, right, in a record we should consider to be the keys. So let's just take a look at some ideas, some examples on how we might capture some dependencies amongst fields. And so here in this case we have students and the semester that they're currently in, and the lectures that they're coming to, and the TAs. And again, as you are inspecting this, you realize that this student ID, if you know the student, well, that student can only be in that particular semester. It would make no sense for the same student to be in two different semesters, right? So there certainly is a dependency between the two. If you know the student, you know the semester. Maybe not the other way around. But certainly one way, right? The dependency direction is from student to semester, right? Meaning, if you know the student, you know the semester. So there's a function, right? The semester is a function of the student, right? If you know the student, you know the semester, and we could formally capture it as a function like this, right? That y is a variable of x, right? As you change x, y changes, right? Where you have the x being determinant and y being the dependent. A couple more that here that you have a lecture from a student that is taking a couple of lectures. We might find that if we create some constraints, that this student ID can only be taking that lecture once. Right, that there's no way that this student would repeat that is taking that lecture twice. Right, the combination has to be unique. You can then determine that because of that lecture, there's only one TA that is the TA for that particular lecture. Right, and if you know the TA, you might also know what the semester is. So some of them might be evident. Some of them might be a little more subtle. But you need to be able to catch these things. Typically, from business rules, business rules that might be determined early on, such as you can't be enrolled in the same course twice, okay, or that a professor can only be teaching a course or a particular section once, right? So these types of business rules is what we need to use to be able to start identifying which fields depend on each other and looking for these danger of inconsistencies. Okay, so we want to formally try to identify which set of fields might depend on other fields, right? Where we have X here might be a set of fields, and Y might be another set of fields, right? In general, and what we like to be able to find out, are there any relationships that, given X, we might know Y, right? Given any set of fields, are the other set of fields determined as well? If I know those fields, am I able to predict what the values of the other fields should be? Ideally, these X would only ever be keys, right? The unique keys. That all the fields would only be dependent on the keys, right? And that would be okay. We're okay with those dependencies. But if these are anything other than the keys, right? There's some fields that we cannot guarantee their uniqueness, then those would be redundant, right? Because we can't guarantee their uniqueness. So let's take a look at some business rules, right? So and what clues might we use to be able to identify some of these dependencies. So here's this rule that says a professor can only teach one course. Very, very restrictive, right? Where you have here's the rule. We're enforcing it here in the section table. That we said that the unique identifier for the section. We have a foreign key to the course for this section, the name of the professor, the year offered. Okay. So here we're enforcing it because the professor is only being represented only in that one section. Okay. Right, and you only have one course given that section. Right. So that's already being enforced, right? That's already being enforced. But what if you introduce other constraints, other rules, right? Might they be inconsistent with prior rules, right? Might say, for the same value of professor, you have the same value of CD, right? We already have that, right? We already have that. If you know the professor. Right? If you know the professor, you definitely know the course. Right? But notice that these two are not primary keys. Right? The primary key is this one over here. Right? That if you know the professor, presumably you would know that because they can only teach only one course, you know that Einstein can only ever be teaching physics. Right? They can't be teaching dance. Right? And that it would be a violation of this rule if we would allow Einstein to be teaching anything other than physics, right? But there's no way for us to enforce this, right? There's no way to catch it. There's no way for the database saying, there's something wrong with your insert or your update. You see that? Right? We could maybe enforce it at the application level, maybe, right? But there's no way for the database to enforce this. Right? So definitely this would be a dependency that we need to look at, right? That there's a risk of inconsistency. We could inadvertently, right, change this to physics, and we wouldn't know, right, that we're breaking a rule. Nobody would tell us. There was no exception. Nobody caught it, right? So we need to eliminate these dependencies. We need to remove these dependencies. So if you have X and it tells you Y, this is again some formal jargon, some formal notation of how you would write given a set of fields. Do you also know those other fields? Right? In each case, you might have multiple attributes. So, for instance, in this rule that says all sections in a year must be taught by the same professor. So, if you know the year and you know the course, right? For all sections, right, in a particular course, they need to be taught by the same professor. Meaning, we can capture that dependency of the course given a particular year. You know what the professor is, right? And if you have that in one single record, right, you have a dependency of several fields among several fields, right? And we need to remove these because there's no way for us to enforce this, right? Unless we decide that this is a primary key, right? If we decide that this is a primary key, then there's a way for us to enforce it, right? But if these are not primary keys, there's no way for us to enforce the uniqueness. So functional dependencies x1, x1, x2, and xn give you a value for y, and these are all driven, right, or they're all derived from rules like these, right, where we have all sections professors teach are from the same course, right. Notice that there was no need for us to inspect any data, right. It was from us reading the rule, right, looking at the fields where how we're representing that data, seeing that those data are not primary keys, right, and that they're combined amongst each other, and how they're related to one another, without inspecting. The idea is that you don't need to inspect. That's the whole idea, right? So here's another example. All sections professor teachers are from the same course, meaning that if you know the professor and you know the year offered, then you know what the course they're teaching, right? So Einstein can only be teaching physics. Einstein in 1950, Bohr in 1951. So if you know the professor, you know the year, you definitely know that they can only ever be teaching physics. Now, if you add additional rules, like courses taught at most once a year, right? Meaning that if you have the combination of course and the year that it was offered, right, that's going to be unique, and you know what the section that they're teaching. There's only one section that can only be taught by the same combination of professor and year. So if you have both rules, notice that they contradict each other, right? And there would be lots of data that before there was no problem, it wasn't redundant, right? In the previous rule, there was no redundancy, okay? But because we add this new rule, now the data is redundant. Right, it's redundant, and we have inconsistency. Right, we have data that was okay before, but with this it breaks this brand new rule. So all your interpretations, whether things are consistent, whether they're redundant, it's always within the context of taking into account all these rules. Right, make sense? So the data would be perfectly fine and has a perfect data model up until somebody gives you a rule that breaks your data model, right? And you have to rethink your data model to enforce those rules. All right, so there is a relationship between these functional dependencies and the keys, right? As we mentioned earlier, we want the dependencies always to be from the fields, right, to the primary keys. Those dependencies are okay, right? The ones that we don't want are dependencies amongst the fields, right? So because dependencies between fields and the primary keys are okay, we can actually use these clues as a way for us to choose what those keys are, right? As a help of identifying what those keys are. If you remember what superkeys were, superkeys is just a combination of fields that in your rules should be unique, right? Now you might have more fields in there that don't make you any more unique, right? So we refer to it as some of those keys we might consider as superfluous, right? If I use my phone number or my social security number, at least in this country, that's enough to make me unique. Yes, you knowing my first name and last name doesn't make me more unique, or the combination of my social security number plus my phone number doesn't make me any more unique. Any one of them might be enough as a primary key in this country anyway. In this planet, I guess. Up until Elon Musk gets us to Mars, and then we'll have to think some other additional primary key to add in there. So we can use these dependencies as a clue of choosing what those keys should be, right? To break those functional dependencies. So FDs can help us determine the superkeys right? So for instance, in some of the rules that we mentioned earlier, that we wanted to, we had the rules of courses taught at most once a year, right? That was the rule. And that means that if you know the course ID and you know the year that it was offered, right, then you know the section that it's being taught, right? And because you know that section ID is unique, right? Because section ID is a primary key, right? It's already being determined that it's a primary key. You know that already. And because you've identified this dependency between these two fields, or the combination of these two fields, right, and the primary key, if section ID needs to be unique, well, it has to be that the left-hand side also has to be unique, right? So this is kind of a clue that perhaps you hadn't realized, right, that combination should have been a key in the first place, right? But as you are making the logic and identifying these dependencies, right, you can use these types of dependencies to identify new superkeys or primary keys, right? Right. So if you have the course ID right, that presumably if you have a different combination of course ID and year offer gives you the same section ID, you can't have redundancy of section ID because section ID can't repeat. Right. So if section ID can't repeat, then it must be that the combination of course ID and year offer cannot be repeat either. Right. So it itself is a key. Right. Now whether you might have other fields in here that don't make it any more unique, you might have some superfluous keys in here, right, that you might want to drop, right, to see what is the minimum set of fields that you need for this to be a key, right? And we call super keys that don't have any redundant or superfluous keys, we just call them just plain old keys, right? So just to capture that idea is that if you have a set of fields that are a superkey of some that you already know that it's a superkey, right? Like section ID, you already know that section ID is a primary key, and you have some other arbitrary set of fields that you don't know if they're keys, and you have identified a functional dependency that for a combination of these arbitrary fields, you have a unique representation of some superkey that you already know that it's a superkey. Then by definition, your left-hand side also has to be a superkey. Okay. So identifying these functional dependencies, right, gives you clues at what should you choose to be a primary key or combination of these keys. Yeah, superfluous keys that superfluous keys that don't have. Super keys that don't have any superfluous keys are just plain old keys. Right. So if you have full functional dependencies, right? If you have identified functional dependencies that only depend on the keys, that don't have dependencies with other fields, but only depend on the key, we call that a full functional dependency, right? A full functional are key-based, right? Where your left-hand side is a key. Right, where you have the things that only depend on keys, right? So, and those are the ones that are good. Those are the ones you want to keep, right? That you only depend on those keys. So, in general, right, if you have functional dependencies where the dependency is not on a key, you can make the general conclusion that there will be redundancies. Right? If you have fields that depend on each other, and the dependency is not with a key, you can make the blatant statement that will have the redundancy, and you are at risk of inconsistency. You know, why do these happen? Why do these functional dependencies occur? Right? Did we read the problem wrong? Did we interpret it wrong? What is it? How can we avoid them? So here's an example on a requirement that we might have misread. Okay, so you might, here's I think a modification on the original requirements is that it says the parking permits must list license plates. We're trying to model the license plate for the permit of students being able to park, right? and somebody said, well, not only do I want to know the car model, I also want to know the manufacturer. Okay, and so you might capture it this way, right? You have the student, you have the permit, and it was listing the car models for those permits, right? And you want to capture the relationship of also the car maker for that model, right? And you might want to capture it in a hierarchy that might make sense, right? These are multiple permits, right? And these are all the permits that have been assigned to Corollas, right? These are all the permits that have been assigned to Cherokees, right? All these car models, like Corolla, 4Runner, RAV4, they are all Toyotas, right? And these, the Chevy, the Liberty, and the Wrangler, they're all Jeep. So as far as the data is concerned, right, it's all good. It's all good, right? Now you might be one of the questions as you're deciding how to model this. One of the questions might be that do I really need to have these two tables? Can't I maybe merge this into here? Do I really need a separate table for this? Could all this maybe just be rolled up into just a permit, right? Just a car model, the car make. I'm not Ford Motor Company, right? I don't need to know any specific things about this information. I could just roll it up all into the permit, okay? As individual fields. Yes, that seems like something that might make sense, right? We might decide to roll the whole thing into fields as opposed to as separate classes, like car model and car maker all rolled up into the permit. But when you take a look at this logically, you identify that right there's a dependency between these two fields. Right? You've introduced a dependency that was not there before. Right? That if you know the car model, you definitely know what the car maker is. Right? And by identifying these functional dependency, and they are not keys. Right, neither one of them is a key, neither one of them is a super key, right? You can blatantly say, that there will be a redundancy here, right? And there will be with a risk of inconsistency. So let's see some examples of what the inconsistency might look like, right? That you might say that here's examples of the redundancy, right? If you have the car model, you definitely have the car maker, and you're going to have multiple times capturing that a Corolla is a Toyota, Corolla is a Toyota, Corolla is a Toyota. You're going to have lots of those records over and over, right? If we need to inspect it, right, and identify that there's redundancy here, and since these none of them are keys, there's no way for us to uniquely enforce the uniqueness here, right? There's no way to enforce it. So inadvertently, somebody could insert data there, bad data, like Corolla GM or Corolla Ford, right? That makes no sense. This doesn't map to any reality, right? And it's just bad data. Somebody entered it incorrectly, and the database would have no way to enforce any of this, right? And no way for reporting that there's bad data in there, right? So we want to avoid this in the first place. But one of them, we could just ignore it, right? We could just say, well, it's irrelevant. It's once in a while it'll be a bad data. It's not a big deal, right? I'm a university. Once in a while there will be some bad information in there, and it might not be relevant to me, as for operational purposes. And I might accept the risk. I might just accept the risk. It's not worth doing the over-engineering to avoid this. That might be a perfectly fine decision for your particular domain. Or you might fix it by enforcing referential integrity and deciding that it was a bad idea to make these into attributes, right? That these should have stayed as classes, right? Or maybe one of them could be an attribute, but the other one has to be a class, right? It has to be a separate table and have just a list of all the car makers or the list of all the car models, right? So here's where we went back to we backpedaled and says, well, no, maybe it was not a good idea. Let's just keep the car model over here, right? As part of the permit, and they'll reference to the list where you list all the car models, and in there you can keep track of the maker. So you'll be separate. Now you've removed the functional dependency, and you've removed the risk of inconsistency. Some other examples might have been that as we were capturing the relationship between sections and professors and courses, we might have added this rule that says professor teaches exactly one course, right? Now in the current implementation, right, we have sections with the professor is being just captured only once in the section. We have a separate course table. Right, and adding that rule introduces this functional dependency, right? That because the professor can only teach exactly one course, if you know the professor, you definitely know what the course would be. So definitely, it's a non-key-based dependency. And so the way we could fix it is that we can break out the professor into a separate table and refer to the course that they're actually teaching. Okay.